Hello guys, welcome back to my channel, and to those who are new here, it's Laura here, and I'll be taking you through representing and summarizing data in statistics. So today I'll be focusing on continuous data, but I'll actually go on into describing or differentiating between discrete data, the one we did in my previous video, and continuous data. Okay, so before I got into that, today I want to make some shoutouts. I really like the way you responded in my first video when I began the shoutouts, so I'm just going to continue, right? Okay, so shoutouts there's praise Takawira Sombi. Oh, thank you so much. Thank you. And please continue to like, subscribe, and comment. I really enjoy your comments, and they really push me forward. They just make me feel. You just can explain. Okay, fine. So I want to also give a shout out to Lawrence Mantaro, and he actually pretty said something that actually got me going young, guys. And I was actually thinking of, what about we talk about going younger, doing it now, in our 20s? I don't know how you see about it, but I actually feel to have to say something about doing it now. I hope I will have some other people who are kind of a bit crazy, like we just go for being now. They just do it now. Why not now, guys? I don't know. Okay, and I also give a shout out to Tawana Madan, my mom. Thank you so much. Thank you. Okay guys, so today I'll just go back to my video. Thank you so much. So please continue to like, subscribe, and comment for you to be mentioned in my shout out. Okay. So okay guys, there's another thing that I wanted to mention. As you can see, I'm about to reach my 100 subscribers. So instead of reaching my 100 subscribers, so I was actually thinking of doing something special when I reach my 100 subscribers. But you can give me ideas of what I can do when I reach my 100, and please keep on helping me so that I can reach 100 subscribers as soon as possible. So you can just leave your comments, like the ideas that you have for me that I can just do for my 100 subscribers. For you guys who have subscribed to my channel, thank you so very much. Thank you for supporting me. And so today I'll be focusing on continuous data, representing and summarizing data. So as I've said before, I will go back to my discrete data a bit so I can just give a brief explanation and relating it to continuous data, our topic today. Okay, so on discrete data, we made a mention of that discrete data takes only exact values. They have to be exact values. Then, like I gave you an example of tomatoes on a tomato plant. There's no way you're going to get a half tomato on a tomato plant. No, it is only got discrete number of now values, right? And also the amount of tomatoes on each plant, on different plants, varies. Isn't continuous, right? Like isn't the same. It's unordered. You can find 3 on one, you can find 2, you can find 10 on another, but the most thing we are sure of is you're going to find exactly 10. It will be exact. Okay, so for continuous data now, as I was saying, let me just write myself continuous data. Okay guys, for continuous data, what are we saying? We are saying the data is continuous. We have values that, those values you can round them up, either up or down. They are not exact values. That's the main difference. They are not exact values. The values are can be rounded up and down. And we have examples. We can have the speed of a vehicle as it passes a checkpoint, a speed of a vehicle as it passes a checkpoint. Yeah, that can be one point. Like the speed end country it ends constant, it ends exact. People pass the checkpoint with at different speeds. That's just how it is. There's no certain speed. Or, yeah, there might be speeds, but not everyone follows that, right? Okay, there's also the mass of a cooking apple. I'm not really sure what a cooking apple is, but what I'm sure is mass ain't exact. Yes, for some things it can be exact, but we cannot say mass is exact. It's different for everyone. For me, my mass is, last time I remember it was 49.34 something. Thereabout. Okay, kgs. Then there is the time taken by a volunteer to do a task. Oh guys, this is continuous, I mean. This is continuous, this ain't discrete. Because people can finish a task that they are given at different times. Especially when this person is just a volunteer, you don't know this person may not be even qualified to work at a certain speed that will be given. So the time taken would obviously be continuous. We obviously have commas and even the time that I took to prepare this whole setup, I had prepared just 1 hour for myself to do, but hey, the truth being told, I didn't do that. I think I even got to 15 or 16 minutes of the airport. Okay, so I'll give an example. I've got an example of where a survey was taken on 20 children in a sports club site. So it's a survey on the children's height. The children were in the sports club. Okay, so each height, now that I'm about to write, was given to the nearest centimeter. So I'll just write down the height of the students. Okay. Can fit into that. Okay, so we have, let me just write down. Okay, so these are the values that I've got here, the heights of the students. But take note that these values have been mentioned that they were rounded up to the nearest centimeter. Okay, before I forget, I'm using CRAWSHAW. I'm not really sure who wrote CRAWSHAW, but I'll check it out. But I'm using CRAWSHAW to all those who know this text. It's called CRAWSHAW. Okay, so I'll move on. So this is an example of continuous data. It's data that is not exact. You have to round it up for it to be exact, right? That's continuous data. And continuous data cannot take exact values. You've heard me say that continuous data cannot take exact values, but can only be specified, but can only be given only within a specified range. They can only be given within a specified range, or measured in a specified degree of accuracy. Okay, guys. So that's another difference between discrete data and the continuous data. That continuous is got a specified range, while discrete data is actually exact. Okay, so for example, we have 33 here. 33 here could have been taken from this range, like 1, that would be like 132.5 less or equal to height, since we are working with height, less than Okay, so this would be the range with which we would have taken the value. Okay guys, so moving on. So moving on, we're going to go for frequency distribution for continuous data. We now want to summarize all this data. Now this we want to put some kind of an order. We want to summarize, we want to put a frequency distribution for the graph. So I've got 3 different ways. I'm going to teach you 3 different ways. I'm going to teach you on how to make continuous data, how to make a frequency distribution for continuous data. Okay, so these 3 ways involve, do you allow me to rub this off? So I will have height for the first one in centimeters, the height for the second one. If I put it here, it won't be right. I put height here in centimeters, I put height here. Okay, so this is how it is like. So still visible, right? Okay guys, so what is happening now is that for the first one, I'm going to put a range, right? A specified range. But this range, you have to take note that it has to have a specified width. You have to have a continuous and a constant width. Okay, so for my first part here, I'm going to determine my lower limit. Okay, it's from 120. Okay, so 120 is my lower limit, and my upper limit seems to be 138. Okay, so this is my upper limit. 141. Okay, fine. Oh, this is my upper limit. 140. Let's go to 144. So this is my upper limit. I'm sorry for that. Okay, so what is happening in my first example here of how to make a frequency distribution, we are going to say for 120, it's going to be 1. You subtract a 0.5 and you add a 0.5. That's how the will go. So it's going to be 119. Let me use a different color. Okay, so we are going to say 119.5, right? Less or equal to height less than. So since I said I'm going to use a width of 5, so this is going to be 119 to let's add 5. That would be 124, right? 124.5. And also take note of this fact that my upper class boundary, these are class boundaries, these are class boundaries, right? So my upper class boundary for another class will be my lower class boundary for another class. Okay, what I mean is here is 124.5, so I'm going to put 124.5 here, less than h, less than, get it in 124, 125, 124, 26, 27, 28. This is going to be 128.5. Okay guys, so this is going to be 128.5. So this is going to be 128.5. So this is going to be 128.5. 129. Okay, so since 129.5 is my upper boundary, it is going to be my lower boundary in the next class, right? In the next level, 129.5 less than, go to 1, less than. In my upper class, if we add 5, it's going to be 134.5, 134.5, until we reach 1 correct. 134.5 less, less, oh, okay. Okay, 134, so this will give me 139.5. And my 139.5 less than, give me 144.5. Okay guys, don't forget this fact that I've just mentioned. When you are using this first criteria, you subtract a 0.5 from your minimum value, like your lowest value. You subtract a 0.5, right? Then the upper, then you use a certain width. You decide your width. You could use 5 as I did, you could even use 10. You just could use any. But make sure that your upper value, your upper class boundary has got a plus 5, a plus 0.5, a plus 0.5. That's what I mean. Okay, so here we add the 0.5, you subtract the 0.5, and here you add the 0.5. Okay guys, so moving on to my next class. It has got the same criteria as this one, but for this one we do not use the less than and the greater than are expressed with a dash sign, right? So it's going to be like 119.5 to 124.5. So it just depends on what you want to use and which criteria do you find best for you. Okay guys, so it's 124.5. So we just repeat the same order, but putting them this, okay, 0.5 to 129. 129.5 to 134.5. And so on and so on. You just do this for this part. Okay, so for my third criteria, what is happening is I'm going to, you use the exact values. Okay, for my third criteria, you use the exact values. Please take note of the width, and also on my third note, this one you practically don't, you would have rounded up already, like so there's no need to round up here. So you say 120, since they are already rounded, since I mentioned it when I first started this video, like they are not exact values. So like you round them up before you put them here. So it's 122, 124. Yeah, okay. Maintaining the same width of 5. For this point, we are saying 120, 120, 121, 122, 123 to 124. 120 is included since it is within the range. Okay, guys, still we are maintaining the 5 width. That's what I'm saying. 120 to 124, 125 to 129. And also for this part, guys, you have to understand the fact that I cannot put the upper class boundary for this part and the upper class and the lower class boundary for this part, because this part is included, it's being read. So if you put 124 and then you put 124 here, it means if there are 124 values within your certain values that will be given, We are going to read 124 twice. That's what it would mean. So for this part, you have just have to read it once. So you can say 120 to 124. Then you move on. 125 to 129. So here's 130 to 134. 134, 135 to 139 in extra until you reach to your upper class boundary for these values, which is 144. Okay guys, that's it for continuous values. But before you go, let me make mention of the width of intervals. Let me just highlight it as a first time. Okay, for width of intervals, let me just write it down. Width of intervals. Okay, so for width of intervals, what are we saying? We are saying for us to say we have got a width of 5. For a width of 5, right? We are going to say width is equals to the upper class boundary. Upper class boundary minus the lower class boundary. That's how you obtain your with the upper class boundary minus the lower class boundary. Right guys? And also, there is also a way to group or summarize your data using a tally column. You can summarize using a tally column. Okay, this is simple. Let me just show you tally column. Okay, for tally column, you would have used a frequency distribution already, but now put your frequency and your tally and your frequency, right? So let's say height. Centimeters, my tally here, and my frequency. Okay, guys. So this is how it is there. So for the first part, we say it's 119.5 less or equal to height less than 1.24.5. And the second one was 1.24.5 less than 1.2. Okay, it's very unfortunate that I've wrapped it off, but I will show you when I post this video. I will show you somewhere here. The first is these two things. Okay, so for one, you would go back to that table that I had drawn, right? And you look for values that are within this range. You also look for values that are within this range. And for that first part, we had 1. So maybe the frequency of this part would also be 1. And for the second part, we would have the values that occupied were 5. 1, 2, 3, 4, 5. Then we cross out. So we have 5 here. And so on and so on. So this is how the tally system would be done. But also remember that as you put your numbers, as you cross out your numbers here, you also have to cross out the numbers in the column. That makes it much more easier for you to understand and to know where you're coming from and where you're going, unlike just leaving all the numbers uncancelled. So when you find a number, what I keep saying is, when you find a number which is within the range 118 to 124.5, right? For example, let's say for that example, for this example, we've got 120, right? So you have to cross out 120 Means you are now just working with all the values that are not within this range. You have to cross it out to make your work more clear. Okay, guys. But the only problem with this study type of with grouping in this way is that your original information is lost. For example, for this part, we are no longer sure of which exact height was within the range 119.5 to 124.5, right? We are no longer sure which number. Meaning our original 120 was lost. That's how it means. So for this part, we will have to find the best way to group our data without losing our information. So watch out in my next videos when I will be explaining on stem and leaf plots, which actually keep the data, the previous data, the original information there. Thank you guys, and don't forget to like, subscribe and comment.